Good morning. And of course, neutron decay cosmology. So here I'm going to draw that, what do they call it? Like a gluing diagram for how I believe the manifold of neutron decay cosmology works. I'm going to do this way. Oops. I'm looking through the camera, so that's why it's whack. Put an N here, which is where this represents right there is event horizon, and that is where the electron is pushed back into the proton to create a neutron, and that's why I put an N there. And I'm going to put N's out here too, because, oops, there we go, and over here, because premise of neutron decay cosmology is that when a neutron contacts an event horizon, the geometry of space-time is such that it is now shot on the surface of, not the bulk, because there is no bulk, time is compactified, but in that moment, that information needs to re-emerge someplace in the universe to maintain conservation. So it emerges at the periphery somewhere, at the least energetic point of space where it's easiest to appear, where it's needed. And then this neutron expands, which is why this part is larger, actually. Let's put a little flow arrows, right? And flow arrow there, and there, and there. And these flows converge and then continue to flow toward the event horizon, because this is the way everything just flows towards maxima, because that's what gravity seems to do. Okay, so there we go. And this is expanded because the neutron, which is 0.6 femtometers cubed, more or less, decays into 1 cubic meter. It expands. And then, this is why the universe is so full of voids and blackness. And then that hydrogen gets recompressed until it hits event horizon, where it gets transported via topology that I have in other videos to the periphery to do it again. And that seems like, okay. And one thing about neutron decay cosmology is that I postulate a single-sided surface for us. Because it's a single-sided surface divided into two regions, connected via event horizons, because it is a single-sided surface, when matter falls into an event horizon, it actually doesn't become a neutron. It becomes an anti-neutron, but since it's a single-sided surface, if there is a neutron, there is simultaneously an anti-neutron. Because if this was one-sided, I could flip it over, but it's single-sided. So when I flip it over, all you get is a bunch of anti-neutrons behaving exactly the way neutrons would, doing exactly the same things that neutrons would, only on the other side of time itself. This is why the single-sided surface works. And also, if you think about it, when renormalization, what happens? You push something to maxima. You push it beyond the limit. You push it to quote-unquote infinity, local infinity, the maximum we can get. What happens to it? It doesn't disappear. It doesn't go someplace in time, weird. It becomes the anti of itself, because you pushed it through onto the other side, or drew it onto this side, however you want to describe it that way. But anyways, there we go. Neutron decay cosmology.